All right, so now we're going to start chapter 19, which is about electrochemistry. And so, yeah, this is kind of a long chapter, but we'll get through it. Electrochemistry pretty much deals with the idea of oxidation-reduction reactions. These are affectionately referred to as redox. I say affectionately like anybody cares about this, but the RED of reduction and the OX of oxidation makes redox. I usually kind of think redox sounds dumb, so I may or may not say it. I don't know. We'll find out. So these are two separate processes, kind of like when we had acid-base reactions. Acid is one thing, and an acid is one thing and a base another thing, and they have to react together. You can't have one without the other. Same thing here. So let's define these things real fast. Oxidation is when an element loses an electron to become more positive. Okay, reduction is the opposite. This is when an element gains electrons to become more negative. Okay, so we're going to see these a lot this chapter, but I figured starting out by defining those things is probably the most important place to start. The very first thing we need to worry about is how to balance redox reactions. All the stuff we learned how to do last semester about balancing chemical reactions is technically correct, but it's a little more complicated for redox reactions. So let's see what we can do. There's a step-by-step method, and it is kind of useful to follow it. I guess technically it might be possible to ignore it, but I don't know how. So half reactions method of balancing redox reactions. So some of these steps won't make any sense until we try some examples, but essentially what we're going to do is we're going to divide it up into the oxidation and reduction half reactions, and then we're going to balance those separately, make the electrons cancel out, and then balance it back together. Anything with electricity, with redox, there's going to be electrons floating around. Okay? So the first thing we do is we separate the two half reactions. The oxidation is one half reaction, the reduction is the other half reaction. You don't even actually really need to know which one is which in this, you just need to separate them. Okay? It's not as hard as it sounds. Step 2 is you balance the atoms in each half reaction. This feels like how we used to balance typical chemical equations. There is a slight little caveat to this. If you are under acidic conditions, so when we talk about batteries or voltaic cells, you're always under acidic conditions or basic conditions. If you're under acidic conditions, this always happens in water, which means that in theory there should be H pluses or H2O anywhere, wherever we feel like, and we can add it whenever. So even if the reaction doesn't have H2O or H plus on either side of the reaction, we can add it in there if we need to. Under basic conditions, essentially, because it's basic, you can add OH minus or H2O. I'm going to put a little star by this one. I'm actually going to teach you a weird way to do that. It's kind of a workaround because honestly, this is kind of a pain. At the end of this step, you should have two half reactions and the atoms should be balanced, and there will probably need to be some charges that balance out. So step 3 is you can add electrons to balance the charges of the reactions. It's pretty easy as long as you're diligent and careful. Step 4, what you do is you take however many electrons are in one half reaction, however many electrons are in the other half reaction, and you scale them up so they can cancel out, and then you combine the two reactions. So scale up the reactions so the electrons cancel out. Then combine and simplify. Okay. So, sounds all good and great. Let's try an example. Acidic conditions tends to be the easier option, so let's start with one under acidic conditions. Okay, so here's an example of a redox reaction. Let's say we take MnO4, which is manganate, and react it with thiosulfate. Doesn't really actually matter if you have any clue what these polyatomic ions are. And the products are Mn2 plus and SO4 2 minus. So if we look back at the steps, which I guess I'll keep handy here, the first step is we separate the two half reactions. Honestly, what I usually do is I kind of ignore the oxygens and the hydrogens, and I just this is a manganese and this is a manganese. This is one half reaction. This is a sulfur compound and a sulfur compound. This is the other half reaction. One of them is oxidation and one's reduction, but we don't actually really need to know which one is which right now. So one half reaction is this manganese compound becoming this manganese compound. So I'm going to recommend, it sounds counterintuitive here, but you're going to write this in the middle of the page. The other half reaction, we're also going to write in the middle of the page, is S2O3 2 minus, becoming sulfate. So this is one half reaction, this is the other. We're going to deal with them one at a time. So we've separated the two half reactions. Now, since we're under acidic conditions, we balance the atoms and we add H pluses or water as needed. So double check anything that isn't oxygen or hydrogen first. We have one manganese. Great, we don't need to put any numbers in the front. We have 4 oxygens and no oxygens. Well, we can add hydrogen or water. Water will give us oxygen, so let's do that. So we have 4 oxygens on this side, so we're going to need 4 oxygens on this side, and this is the only way we can get oxygens as far as we know. Okay, great. Well, now we've introduced a bunch of hydrogens. There's 8 hydrogens on this side, so now we need 8 hydrogens on this side, and we can add H pluses wherever we feel like. This is what I mean by acidic conditions. We can add waters or H pluses wherever. Okay. So, step 2, we have balanced the half reaction under acidic conditions. We have 1 manganese, 4 oxygens, 8 hydrogens, 8 hydrogens. The atoms are balanced. I'm actually going to go ahead and do step 3 for this half reaction before doing all of it for the second reaction. So we need to balance the charges. Adding up the charges requires some diligence, just go slow and be careful. This is 8 times something with a +1 charge, so that's 8, and this whole thing has a -1 charge. So this whole side is a +7. This is 0, and this is +2. We do not need both sides to be 0, we just need them to be equal. Electrons have a -1 charge, so whichever side is more positive, you're going to add electrons until both sides are the same. Since this is +7 and this is +2, the difference is 5, we're going to add 5 electrons to this side. That will bring this whole side down to a +2, which means this will be the same. Okay, now let's do the whole thing again for the other side, or for the other half reaction. Start out with the non-oxygens and hydrogens first. We have 2 sulfurs and 1 sulfur, so we need a 2 here. Oxygens, we have 3 here and 8 here because we added that 2 in the front. Okay, 3 and 8, so we need 5 waters on this side. Okay, that gives us 8 oxygens total, and now we have hydrogens. We have 5 times 2 would be 10, so we need 10 hydrogens here. Okay, our atoms are technically balanced. Now we're going to balance the charges. Okay, so this side, we have 0, and there's only one of these, and it's -2. So, -2. This side, we have -4 and +10. So this side is +6. Okay, right? 10 minus 4 is 6. So, to get down to, whichever side is more positive, that's the side you add the electrons to. To get this down to -2, we're going to have to add 8 electrons. 10 minus 4 would be 6, minus 8 would be -2. As long as they're the same, we're good to go. Okay, step 4. Step 4 says we need the electrons to cancel out. So we can scale up the half reactions by whatever we need to make the electrons cancel out. So we need to find the least common multiple between 8 and 5 so that the electrons will cancel out. Turns out that the least common multiple between 8 and 5 is 40. So we're going to take everything in this first reaction times 8. That'll give us 40 electrons. We're going to take everything in the second reaction times 5. Okay? This is going to get a little messy. Be very diligent and careful about applying these 8s across the board. At this point, the electrons should cancel out. If they don't, we can't really do the next part. But now what we do is since we separated the reactions, we're going to combine them back together with everything scaled up, and we're just going to cancel out whatever we can. So we need the reactants of this and the reactants of this on one side, and the products of this and the products of this on the other side, with everything scaled up. So for this top one, 8 times 8 is 64 H pluses, plus 8 manganese, or manganate, sorry. And then from this reaction, 5 times 5 is 25 waters, plus 5 times S2O32 minus. I'm kind of running out of space, so that's the reactants. It's supposed to be a 5. Sorry, that looks horrible. Now for the products, this side we have 8 manganese plus 8 times 4 is 32. Okay. And then from this reaction, we have 8 times 2 would be 16 sulfates. And 8 times, or sorry, I am totally wrong here. We're doing 5 times here. 5 times 2 would be 10. Let me mark that out. 10 sulfates. And then 5 times 10 would be 50 H pluses. Sorry, this is why I said you gotta be diligent. Obviously I can mess it up too. Now we're gonna go through and cancel out anything that's the same on both sides. So H pluses, we have 64 here and 50 here, so we can cancel 50 off of both sides. This goes away, and this becomes 14. Waters, we have 25 here and 32 here, so we can subtract 25 off both sides. 32 minus 25 is 7. This is the new final balanced equation. We're going to rewrite it just to make it look pretty. 14H plus 8 MnO4 minus plus 5 S2O32 minus forms 8 Mn2 plus 7 waters plus 10 sulfates. This is technically the answer, but let's double check everything. Okay, we have 14 hydrogens, no more hydrogens on this. 7 times 2 would be 14 hydrogens. 8 manganese, 8 manganese. We'll deal with oxygens in a minute. 10 sulfates, 10 sulfates. Oxygens, we have 8 times 4 is 32, plus 5 times 3, 32 plus 15, we should have 47 oxygens. Okay, over here we have 10 times 4 plus 7, so 47. Okay, so that looks good. Charges. We have 14 minus 8 would be 6, minus another 10 would be -4. Double check that. 14 minus 8 would be 6, minus 10, because 5 times 2 would be 6 minus 10 should be -4. Okay. This side, we have 16 minus 20, 10 times 2. So the site is also -4, which means everything is balanced and we did a good job. Yay. Okay, thanks.